Okay, today we're going to do section 8.3, graphing quadratics from standard form. So here's a couple step-by-step directions. In standard form, in order to graph quadratics, we're going to find the x-coordinate of the vertex, which is also the axis of symmetry, by using the equation x equals negative b over 2a. Then we're going to substitute what we get for that x-coordinate into the original equation and solve for y. That's going to give us the vertex. We're going to plot that and use a pattern to graph. You're going to also be able to find the y-intercept because that's the c of your equation. This is going to be a lot easier if I show you. All right. So we have y equals x squared plus 5. We know that opens up because our leading coefficient is positive. If it opens up, that means you have a minimum for the vertex. So to find your axis of symmetry, we're going to use negative b over 2a. There's no b, so we have 0 over 2 times 1, which is 0. So our axis of symmetry is x equals 0. We get the vertex by plugging that 0 into the equation. So I have y equals 0 squared plus 5. So our y-coordinate is 5, and our vertex is 0, 5. So when we plot that, I'm going to start at 0, 5. That's our vertex. We're going to use the 1, 3, 5 pattern. You can always use this 1, 3, 5 when you don't have a leading coefficient or when it's 1. So we're going to start at the vertex. Here's our 1 over 1 up 1. We're going to do it on both sides. Then from there, I'm going to go over 1 up 3, over 1 up 3. If it fit on the graph, then I would go over 1 up 5. With a parabola or a quadratic, our domain is always negative infinity, infinity, and our range is lowest to highest, so we're starting at 5 and going to infinity. The y-intercept is where it crosses the y-axis, so it crosses at 5, or you can say 0, 5. Either way is fine. Okay, let's do another one. The next one is graph f of x equals 3x plus 6x minus 1. This also opens up because the 3 is positive, the leading coefficient is positive, which gives us a minimum. We're going to find the axis of symmetry by using negative b over 2a. My b is 6, so I have negative 6 over 2 times a, which is 3. So I have negative 6 over 6, which will give me negative 1. So my axis of symmetry is x equals negative 1. Remember that axis of symmetry is a line that splits the parabola into two identical halves. To find the vertex now, I'm going to plug that negative 1 in for x. So I have 3 times negative 1 squared plus 6 times negative 1 minus 1. So I have 3 times 1 minus 6 minus 1, which gives us negative 4. So I have negative 1, negative 4 as a vertex. Let's plot that. Negative 1, negative 4. I'm going to use that same pattern. 1, 3, 5 pattern. But this time I have a leading coefficient of 3. So I'm going to multiply that pattern by a factor of 3. So now 3 times 1 is 3. 3 times 3 is 9. 3 times 5 is 15. So we're going to use a different pattern. Up 1 over 3. Then up 1 over 9. Or I'm sorry, over 1 up 9. So we know that when your A is a whole number like that, you get a stretch and this becomes skinny and tall. So your domain, as always, is negative infinity, infinity. Your range, you started at -4 to infinity. You can find your y-intercept here in the equation, which is -1, or you can find it on the graph where it crosses the y-axis. So we can have 0, -1, or I just can put -1. All right, moving on. Number 3. This time we have a negative leading coefficient, so this is going to open down and have a maximum. Let's find our axis of symmetry by using -b over 2a. So we have -8 over 2 times -2, which will be -8 over -4, which gives me an axis of symmetry of x equals 2. To find that vertex, I'm going to plug that in for x in the original equation. So I have -2 times 2 squared plus 8x minus 3. So I'm going to follow the order of operations. I'm going to square that 2 first. So I have -2 times 4. Oops, I forgot to put the 2 in here. Plus 16 minus 3 gives me 8 minus 3, which is 5. So my vertex is 2, 5. Let's plot 2, 5. There we go. So now I'm going to use that same 1, 3, 5 pattern. I have a leading coefficient of -2, so I'm going to multiply by -2. I have -2, -6, -10. So I have up 1, down 2. I'm sorry, left 1, down 2, or right 1, down 2. Then I have left 1, down 6. 2, 3, 4, 5, 6. And then I have left 1, down 10, and right 1, down 10, but it's going to go off the graph, so I'm just going to graph the rest of it. Domain is still negative infinity, infinity. That's left to right. So this time we have negative infinity to 5. And it's a bracket. Sorry, it's a bracket. My y-intercept is the c in the equation. Or you can see where it crosses to check yourself. See where you can cross the y-axis there. Okay, moving on. Number 4. We have y equals -x plus 4. That's going to open down because we have a negative leading coefficient. That means it's a maximum. The axis of symmetry, -b over 2a. There's our formula again. So b is 4, -4 over 2 times -1. That gives me an axis of symmetry of x equals 2. If I plug that back into my equation, be careful here. I'm going to square 2, which gives me 4, and I'm going to stick that negative sign back on. Which gives me +4. So my vertex is 2, 4. There's my vertex. So I have -1, so I can use -1, -3, -5 as my pattern. Left 1, down 1, right 1, down 1, left 1, down 3, left 1, down 3, left 1, down 5. Our domain, as always, is negative infinity, infinity. My range is negative infinity. Remember, it's lowest to highest. My highest is 4. I'm going to bracket that. My y-intercept is the origin here, so 0, 0. So we're going to rewrite this into standard form first. So if I square this, that's a perfect square trinomial. I have 2 times x squared minus 2x plus 1 plus 7. Now I'm going to distribute. So I have 2x squared minus 4x plus 2 minus 7. That's actually plus 7. So then I have 2, whoa, let me go back. 2x squared minus 4x plus 9. That is my my standard form. I'll put that there. That's going to open up. So it's going to be a minimum. My axis of symmetry will be negative b over 2a. So negative negative will be a positive b. Positive over 2 times 2, which gives me 4 over 4, which gives me an axis of symmetry of 1. When I plug 1 back into my equation, 1 squared is 1. I have 7. So my vertex is 1, 7, way up here. So I'm going to use that same pattern, the 1, 3, 5, but I'm going to multiply it by 2 this time because my leading coefficient is 2. I don't have very much on the graph, so I'm going to go left 1 up 2, right 1 up 2, and the rest, whoa. My rest is going to be off the graph. So my domain is negative infinity, infinity. My range is lowest to highest. So I'm going to start at 7 with a bracket and go to infinity. And my y-intercept is this in standard form way up here. It's 9. Okay, that's it.